Swiftmeisters, this is Prof. G, and in this video lesson we are going to work with images in SwiftUI. And while we'll initially learn how to access the thousands of system images that Apple gives us as part of the SF symbol set, many of the techniques we'll learn will be applicable to other types of images and even to other types of views. But we'll also learn some specific techniques related to SF symbols, including how to work with rendering styles, how to customize colors, and how to work with variable images to use the iOS 16 variable value to activate parts of a system image. So prepare to scale up, let's learn big! So this is where we left off at the end of our prior lesson, and I'm noticing we have a couple of border modifiers commented out, and we don't need those, so I'm going to delete those. And now we're going to work with system images in this lesson. And you, skilled one, have already had some experience with this in one of our first lessons. So why don't we start out with a simple challenge. Update your app to add an image that looks like this. The message string should read Namaste. The image to get the meditating person is figure.mind.and.body, all lowercase. The color should be pink. And size this as shown, no distortion. You should keep the same height to width aspect ratio. Notice we can see the whole image, and the image should resize when using devices with larger or smaller screens. So you learned how to do all of this already. Why don't you pause? Feel free to go back over your notes or look at an earlier video if you need some help. And when you're ready, resume, and let's compare answers. So I'll create an image view under Spacer. I do that by typing in capital image, and there are lots of ways to create an image view. But remember, when we work with the Swift symbol in the earlier lesson, we use this one with the systemName parameter that accepts a string. So let's choose this familiar guy. And for our string, we want to enter our image name between double quotes. And as indicated, this is figure.mind.and.body, all in lowercase. And that gives us this tiny little guy. So let's make him bigger. And remember to do that, we add the .resizable modifier parens after it. We always have parens after our modifiers. And we see that it's distorted, but we know how to fix the aspect ratio so that the original width and height is retained even as we resize the image. We use the .scaledToFit modifier with parens after it. And to make it pink, we add the .foreground color modifier passing in .pink. Quite mellow, and we change the message string up top in our state variable to Namaste. And hopefully your Swift skills are looking quite zen, and if you struggled with that, don't stress. Just keep retrying till you got the skills down cold and you're super chill like this dude here. So now I want to show you another scaled modifier called scaledToFill. And before we try it, let's look at a comparison between scaledToFit, which we were using, and scaledToFill. Now scaledToFit fits the entire image into the view, but it might leave space in the view if the image's aspect ratio doesn't match its enclosing view. And we see here in this example that we can't fill the available space without cutting off some of the image, so this is the best we can do to fit the entire image into the view. Now here's scaledToFill. The goal is to fill. It fills the available space, but some of the image will spill outside of the enclosing view if the image's aspect ratio doesn't match its enclosing view. So the goal here is to fill the view, even if that means some of the image spills out. The goal here is to fit the view, even if we can't completely fill up all of the space that's available. So now let's try this out in our code. First, to make it easier to see the space that the image is taking up, I'm going to add a .border modifier to the image, passing in .pink, and I'll also add a .border modifier to the text view, passing in .blue. So here with scaledToFit, we see the entire image, but we don't fill the available space. Remember, our code has a spacer above the image and it has a spacer below the text, and those push the image and the text to the center, and this little gap that you see in here is just the standard amount of spacing for the VStack. Remember, you could pass in a spacing parameter to set this to 0 if we wanted to get rid of that, but you usually want to keep padding in between views. But now let's change scaledToFit to scaledToFill. So while code completion says scaledToFit scales the view to fit its parent, arrow down to scaledToFill, this scales the view to fill its parent, and what it doesn't say is even if that means letting some of the image spill out of the view. So let's select scaledToFill, and now the view is filled with the image. There's no extra space, so the spacers actually do nothing here, and that's because spacers are flexible and they expand to fill the available space, but scaledToFill is already filling the available space. But we don't see the whole image in here. That's because in order to fill up the available space without distorting the image's original aspect ratio, some of the image had to spill out on the left side and the right side. Cool. Sometimes you want to fit, even if that means leaving some blank space. Sometimes you want to fill, even if that means some of the image is going to spill out. Now notice I said spill out. It's not really cut off, and let me show you what I mean by that. So with scaledToFit, we don't see any part of the image spilling out because it's off screen. But watch what happens if our container is smaller than the space available. Try this. Let's add a 200 by 300 frame to the image. So I'm going to add a dot frame modifier. I'll highlight the option with width and height, and I'll option return to enter all the parameters. I'll set width to 200, height to 300, and I don't need the alignment, so I'm going to delete that. And to show the frame that we just added, I'm going to add a blue border after the new constraining frame. So the pink border is the border of the image, and the blue border is the border of the frame that constrains the image. But ho, look what's happening. The extra image in scaledToFill is outside of the blue framing rectangle. What would happen if we switch scaledToFill to scaledToFit? The image is entirely inside of its framing rectangle. Interesting. Let's go back to scaledToFill, and what if we wanted to crop out any part of the image that was outside of the 200 by 300 framing rectangle? Well, we simply add the .clipped modifier after the .frame modifier. This is similar to the clippedShape modifier that we saw earlier. It just clips the image to the size of the view that contains it. So notice the code completion description clips this view to its bounding rectangle frame. The view is the scaled image. The frame is the image's frame modifier. Press return to accept this. The image is now cut off rather than spilling out of its constraining frame. Nice! So that's scaledToFill, plus the very handy clipped modifier. And now that we've demonstrated this, I'm going to switch scaledToFill back to scaledToFit, and I'm going to delete the last three modifiers in the image, the frame, clipped, and border blue. I'll also get rid of the blue and pink borders too. Well, now you might be wondering, if there's an image with the name Swift, and there's this figure, mind, and body with this meditating guy, what other symbols are there? Well, Apple has an app that you can use to browse the symbols and see different features. These symbols are called SF symbols, and if you search online for SF symbols, you'll find Apple's page where you can download the latest version of the app. Now, these symbols are in what Apple calls the SF symbols font family, and the firm is constantly adding new symbols. There are already thousands of these, and it also offers new rendering features for the symbols. So there's a very good chance that at the time you're watching this video, there are even more symbols and even more features, and that the app that I'm about to show you is slightly different. So why don't you pause and download and install this app? I've already got it on my computer, so I'm going to launch it with Spotlight, pressing Command Space, then I'll type in SF symbols, and the app launches. Now you can scroll through all the symbols, and again, there are thousands of them. And you also see this app has familiar controls to show or hide panes on the left or right-hand side. You can also use the search box to search for symbols. So here I've pulled up Swift, cool. If I enter weather in the search box, we see the different weather symbols. There are quite a few here, and we're going to be using these when we build a weather app later on in the course. And now you see over on the left-hand side, there are different categories. What's new, multicolor. These don't look colorful, but we'll see how to change that in a bit. There's communications, devices, gaming, transportation. Human has familiar icons that you might use for things like user profiles. There's math, health, time, lots of stuff. Let's check out weather again. And these symbols each have a name. You see the name underneath. And the one that I'd like us to use in this lesson is called cloud.sun.rain.fill. That's this one here. And instead of remembering and typing in the name, I can right-click and then select Copy Name and then return into Xcode, and I can paste it into my system name string. And when you look at that, that very same image shows up in our app. And now I can also change the foreground color, blue, indigo, pink, orange. And this is nice. Orange works really well for the sun, but it doesn't necessarily work well for raindrops or clouds. But you actually have quite a bit of control over some of these symbols. And let me demonstrate this. First, I'm going to delete the foreground color. Then let's head back to the SF Symbols app. Click to expose the rightmost pane, and then click on the Paintbrush tab. Now, the rendering option will actually let us change the display of these different symbols in our app. Now the default is monochrome, and we see there's just one primary color listed here. It's black, and that's what we've been using, but we also saw that we can change that using foreground color. But let's look at the other rendering options in this pull down. We see we have hierarchical, palette, and multicolor. Let's select hierarchical for now, and notice this panel below the rendering pull down. So after selecting hierarchical, the second image has a blue indicator dot underneath it, so this shows that this is the hierarchical image, and this image also matches what we see in the list of symbols. And we can see the hierarchical option shows one primary color. It's black initially, but some of the symbols, including the one we're working with, show part of the symbol colored in gray. So why don't we head back to Xcode, and we can add a modifier underneath the image to choose the rendering mode for the symbol images. Now the modifier is called symbol rendering mode, and we see in code completion this sets the rendering mode for the symbol image, and it accepts a symbol rendering mode data type as input. So we'll select this modifier, even if you don't know what a symbol rendering mode is. Period shows you options, code completion kicks in, and sure enough, we see the system rendering modes which match the SF Symbols app, multicolor palette, hierarchical, and monochrome. So let's select hierarchical, and look at that, black cloud and gray sun and rain, just like it was in the app. I'm going to add standard padding below this image, and then I'm going to head back to the app. And under the rendering hierarchical selection, we see color, and there's only one color, primary. I wonder what would happen if we change the foreground color. So why don't we try that? So just before the padding, I'm going to add .foreground color and set that to .orange. And we see, hey, look at this. We've got a nice solid orange color cloud, but we've got the kind of gray effect on the sun and the rain. Now that's a good color for the sun. We could try different colors in here like indigo. Everything has sort of a purplish hue, but there are other things that we can do as well. Let's delete the foreground color and head back to the app and see the other rendering modes. So if we pull down palette, whoa, this is pretty cool. We now see we have multiple colors. We see a primary and an accent color. It looks like it supports a third color too, but I guess the default for SF Symbol doesn't use that third color in palette mode. And if we take a look at our cloud, sun, rain icon, it looks like the cloud is the primary color and the sun and the rain are the accent color. Let's head back to Xcode and try out the palette rendering mode. So I'll change system rendering mode to .palette, and hey, I don't see any change. This looks like monochrome. Well, there's a way to fix this. We can add a modifier in the same place where we added foreground color, but this time we're going to add something called Foreground Style. And you see one of the options here has primary, secondary, tertiary. And we look at the code completion description and it says sets the primary, secondary, and tertiary levels of the foreground style. Now these are listed as shape style types, but we learned in an earlier lecture that colors fit in as a subset of shape style. And I'm first going to try to replicate what we saw in the SF Symbols app. So I'm just going to select this option that has two inputs, primary and secondary. So to mimic what we saw in SF Symbols, I'm going to set black as the primary color. The second color is blue, or the accent color. And this is cool. We get the black cloud and we get a blue sun and rain. Now I'm going to try to set colors that look a little bit closer to what we'd see in nature. So since the cloud is black, I'm going to change that black color to .gray. The sun here is blue. I'll change that to .orange. And I wonder if the rain shows up as the third color. Let's try this. I'm going to enter a comma in the third color. Why don't we make that .blue? And oh, look at that! Cartoonish, but the colors look closer to nature. So there's a lot of flexibility in adding color when using the palette symbol rendering mode. Nice! So I'm going to delete the foreground style, and then let's head back over to the SF Symbols app, and we see we've got one more symbol rendering mode, and instead of pulling down the menu this time, I'll just click on the last icon in this horizontal list below the menu, and it switches to multicolor just as if I selected it from the menu. Now multicolor only shows a primary color listed under the rendering mode, but if we look at the symbols, there are definitely some custom colors going on here, and these are the colors that are suggested by Apple. Now only some of these symbols show colors, but you'd see more if you scrolled through the list. So now if we look at our icon, cloud, sun, rain, fill, it looks like the cloud and the background are white. The cloud actually is white, but the background is really transparent. So if we set our own background color to a color other than white, we would see a white cloud in here as well. And you can get a sense for this if you go up to the background pull-down menu and select custom. So why don't we head back to our app and try this out. We'll change our rendering mode to .multicolor, and look at that. We see the multicolor icon, but the cloud is invisible, but we know how to fix this. We'll add a background color with .background, and why don't we make this color .gray, and look at that, now we can see our cloud. But the gray is, I think, actually too dark. We can try different colors in here. How about .teal? And that's not really what we want. And you'll find yourself sometimes thinking that none of the default colors provided by Apple are really the right color for your app. Well, there are lots of ways that you can add custom colors to your app. We could use the sky blue color that we created in the prior video, but let me show you another way. This time we'll pick the color directly from the Attributes Inspector, and it's a little tricky to use, so why don't you follow along. To pull up the Attribute Inspector for the image view, I'm going to Control-Option-Click on Background. So I see a bunch of different options down here, and I'm going to go down to the area that says Background. Now I do find that this is a little quirky in Xcode, so when I'm clicking on Background where it says teal here, I'm noticing nothing else is showing up inside of the pull-down menu, and we do expect to see something here. But there are ways that you can tweak this to find the options that we want. I'm going to click back in my code, I'm going to change .teal to capital C color.teal, and then I'm going to option click to pull up the Attributes Inspector again, and sure enough, under background, we can see different colors in here, and if we scroll to the bottom, we can see an option to select custom colors. But this gets a little quirky too. So select custom, and whoop, there we go. It looks like the color picker popped up really quickly. It selected a color on its own, and then it came back, so that's why things are red. Hopefully these bugs have been fixed in the version of Xcode that you're using, but no fears, we can get the color picker to pop up again. So head back into background, and by the way, notice the way that this menu is broken up. The top are Apple's official colors, but below that are the colors that we created in our prior lesson. We'll ignore those colors and select custom because I want to show you how you can create a custom color right here. Here's our color picker. Now you can use this rainbow on the right-hand side to choose the initial color that you're interested in. So here I've selected a light blue, and then in the middle of the square, there is another little cursor that you can use to select your color. In fact, you can hold down the mouse and drag around, and we can see in real time our background color is changing, and you can really sort of refine the color that you want. I'm going to choose this light blue right here. I think that's good. Then I'll click once outside the color picker to dismiss it, and once outside the attribute inspector to dismiss that. And hey, take a look at the code that was added. So we see color with parentheses in here, and Xcode has added a hue, saturation, and brightness. So there are lots of ways to depict a color. In an earlier video, we showed two different methods to use RGB values from 0 to 1 or 0 to 255, and this is another method using settings for hue, saturation, and brightness from 0 to 1. I certainly wouldn't have known these numbers off the top of my head, but the color picker nicely grabbed the three values that were appropriate for the color that we selected and put those right in here. Now, if you work with a designer, your designer actually might have some specific values. Now, really, if you're going to use the color in more than one place, it probably makes sense to set up the color in the asset catalog like we did earlier, because it's easy to just change that color in one spot and then have it reflected all over the code wherever you use that asset catalog name. So there are lots of ways that you can enter colors, but if you're prototyping and you want to try out colors really quickly and see how they look directly in your app, the color picker and the attribute inspector can be useful, and now you know how to use it by working around some of Xcode's quirks. So now let's add a few more tweaks to get our image to look even nicer. So first, I'm noticing that the image is touching the border, but if we add a dot padding modifier in front of the background color, then we can see this adds a little bit more padding. It pushes the image in a bit on all four sides, and since the background color comes after this first padding, the background color includes that padding, but the padding after the background color pushes it out even further from the edges of the iPhone. So that looks good. Now the image is rendered in a square or rectangular frame. It might be nice to have rounded corners, and you already know how to do that using the corner radius modifier. So let's add that after the background color so that we can be sure that we apply the corner radius after first applying the padding and the background color that's around the padding too. So we'll say dot corner radius, and we can experiment with different values. 5 is not much of a corner radius. 30 looks pretty good. You can put in 150. Whoa, it's almost circular. Let's go back to 30. I like this. But hey, here's a bonus for you. So many times when building apps, you want an image to be inside of a circle. This is really popular when showing user profiles in social media posts, for example. Well, there is a super easy way to do this too. So for now, I'm going to delete corner radius, and instead I'm going to use a modifier called .clippedShape. And the description here says that this sets a clipping shape for the view. It takes one parameter, shape. So I'm going to select this, and then inside the parens, I can type in circle with a capital C, open and close parens. Circle, like rectangle, is a valid shape, so we can pass that in here. And will you look at that? Our image is in a perfect circle, just like the gram. So that's looking good, but I'm going to undo this because I really don't want the circle now. I'm going to go back to .corner radius 30. I think that looks better in this app. But hey, it would be really cool if we could add a shadow effect to make it look like our image was floating above our app. Well, my friends, as they say in Spanish, si se puede, or yes we can. The modifier for adding a shadow is named simply .shadow. So let's add that bad boy underneath the corner radius. The description says it simply adds a shadow to the view, which is what we want to do. Now we get 4 parameters. The color is the color of the shadow. Radius is the amount of blur. So this is a bit different from radius when we talked about corner radius. The larger the number, the more blur. The shadow will seem more dispersed. And X and Y are the offset for the shadow. Positive X value, shift the shadow to the right. Positive Y value, shift the shadow down. Now, other than radius, these values are optional. So I'm going to start out by first testing the radius parameter, and then I'll add the other parameters after that. So why don't we start out with a radius of 5? That's a really tiny shadow. And in fact, if you had a color in front with color, colon, and then I'm going to put .gray in as the color, comma, we see the color doesn't really change. So the default color is almost gray. I think the gray makes a natural shadow, but I'd like a bigger radius. I'm going to change that to 30. Ooh, much cooler. It really looks like the image is floating. So now why don't we shift the shadow to the lower right corner. So we'll add after the 30, comma, X colon 20, comma, Y colon 20. Shadow is shifted, looking good. Now one more thing you might want to do is you might want to put a border around the image too. And this is a little bit more complicated, but not too much. We'll show you how to do it so you can repeat this on your own. Now you might think, well, I've used the border option before, so why don't I use .border, and I'll choose this option here where I can add in a color, .red, and width at 5. And oh, well, that shows this with sharp corners for the border. That's unexpected. But how about if we add another corner radius under here? So if we say .corner radius 30, because we've got a quarter radius above, and oh, look at that, it clips the corner of the border. So that's not at all what we want either. Well, what we have to use here instead is what's called an overlay modifier. So first I'll get rid of the border and the second quarter radius that we added. I don't want that. And underneath the shadow, we're going to say .overlay. And there are a few options in here. I want to select this one that has style as the required argument, and it says ignore safe area, but we won't put that in. That's optional. Now, code completion here says that this layers the specified style in front of the view. And we see that this accepts a shape style, so I'm going to press return to accept this, and a shape style can be a shape. And just so that you can see this better, I'm going to put the two parentheses on two separate lines, and I'm going to put my shape inside here, almost like these parentheses are curly braces, and it's totally okay to format your code like this. Hopefully it makes the code a little bit easier to read. The shape that I'm going to put inside here is going to be a rounded rectangle, and there are a few different options. I'm going to select the one with corner radius. I'm going to put the corner radius in as 30, and oh, this is not what we want. It's entirely in black, but fear not, we can change this. I'm going to head below the rounded rect, and I'm going to enter another modifier here called stroke. Now we have a bunch of different options with stroke. Now I'm going to select this first option here that shows a content and an optional line width. Look what code completion says. It says it traces the outline of the shape with a color or gradient. Remember, a shape style could be a color or a gradient, and I do want the line width, so I'm going to hold down the option key and press return. Both those parameters are in here. Now for starters, to make this look prominent, I'm going to add the color as .red and the line width as 5, and we can see that this shows up exactly as expected. This is cool, although that's not really the effect that I want. I think from a design perspective, it's a bit garish. I want the outline to be subtler, so I'm going to select a line width of 1, and for a color, I'm going to select one that's closer to the blue that I'm using. How about .teal? And that's looking good. Now there's one more thing that I want to show you, and that's been added since iOS 16 and SF Symbol 4. That's variable color. Now not every symbol supports variable color. You can click on the variable selection on the left side of the SF Symbols app to see the current subset that supports variable color. But for those that do support variable color, you can create an image view with a second parameter, variableValue. This is a decimal value that's called a double in Swift, and it can be a number from 0.0 to 1.0, and depending on the symbol, that variable value can determine if parts of the symbol show up in full color or if they're dimmed out. Here's an example. The Wi-Fi symbol supports variable value. Pass in a variable value of 0, and you see the waves of the symbol are all dimmed. A value greater than 0 up to 0.33 will fill in the first wave, that first little triangle. 0.34 through 0.67 will show the second wave, and above 0.67 will show the full signal. Now this is a nice feature. Most apps won't take advantage of it, but let's go through a quick example just so that you can enter some code and see how it works. So one use case for this is to adjust the variable value of a speaker symbol to indicate the level of loudness. So why don't we try this out using this icon here, speaker.wave.3. I'll right click on this and select copy name, then I'm going to return to Xcode, and I'll paste this in as my symbol name. Nice, we see the speaker with 3 waves, but now let's try out the magic of the variable value. So I'm going to click after the string, but just before the closing paren in the image view, and I'm going to enter a comma and then start typing variable, and Xcode recognizes there's a possible parameter named variable value in here. So it suggests that it says, hey, it accepts a double, that's a Swift data type for a number with decimal points. I'll press return to accept this, and I'm going to start out with a variable value of 0.0 in here. All the waves are dim. If I change this to 0.1, I enable one wave. I can go all the way up to 0.33, but 0.34 will turn on the second wave. And then I can go up to 0.66, and oh, it looks like 0.67 is still 2 waves. I suppose that makes sense with rounding, but above that, 0.68, and I see all 3 waves are enabled. Cool. So now I'll go back to 0.0, and the impact of variable value differs according to whatever symbol we're using. For example, there's also a symbol called speaker.wave.2, so I'm going to change 3 to 2, and look at the difference. This one only has 2 waves, not 3. So for a value above 0, 0.1 through 0.5, we turn on the first wave, and above 0.5, we turn on both waves. Cool. So let's clean this up, get our app ready for the next lesson. I'm going to delete the image view because the next time we work with images, we're going to add our own images into an image view. And I'm going to set the message string back to empty string. Our buttons still work great. And once again, my friends, big learning was afoot. We learned about SF Symbols after downloading and installing the SF Symbols app. We learned to add SF Symbol system images by referring to the system name that calls up Apple's lovingly designed symbols. We learned the difference between scaledToFit and scaledToFill, and we learned how to use the .clipped modifier to crop part of an image that spills out of its bounding rectangle. We learned to use various symbol rendering modes: monochrome, hierarchical, palette, multicolor. We learned to create our own 3-color palette, and we set a background color to let the multicolor option pop. We selected a custom color using the color picker launched from the Attributes Inspector. We added a corner radius, and we learned how to use the clippedShape to create an image clipped to a circle shape. We added a shadow, and we learned the special techniques to add a rounded rect border using overlay, rounded rectangle, and stroke. Finally, we learned how to use the new variable color symbols, and we created variations in symbols by adjusting the variable value. You are genuinely becoming skilled. I hope you're enjoying our time together. Keep hacking.